Hi everyone, in this tutorial I am going to explain partial fraction in detail. I solve an example and I give you several examples with a solution. You can practice and solve them and compare the results with mine. Let's do it. Why it's important to understand partial fractions? The algebraic technique of resolving complicated fraction into partial fractions is often needed by electrical and mechanical engineers for not only determining certain integrals in calculus, but for determining inverse Laplace transforms and for analyzing linear differential equations with resonant circuits and feedback control systems. The reverse process of moving from 4x minus 5 over x squared minus x minus 2 to 1 over x minus 2 plus 3 over x plus 1 is called resolving into partial fractions. In order to resolve an algebraic expression into partial fractions, first, the denominator must be factorized. In the above example, we have x squared minus x minus 2. If we factorize it, it becomes x minus 2 times x plus 1. To learn how to perform factorize, I put the link of one of the tutorial in the description of this video. The factorize of x squared minus x minus 2 is x minus 2 times x plus 1. Also, the numerator must be at least 1 degree less than the denominator. In the above example, 4x minus 5 is of degree 1, since the highest powered x term is x to 1, and x squared minus x minus 2 is of degree 2. We have these two conditions. Note, when the degree of the numerator is equal to or higher than the degree of the numerator must be divided by the denominator until the remainder is of less degree than the denominator. Also, I put the link of the tutorial how to divide a trinomial or polynomial equation using long division in the description of the video. There are basically three types of partial fractions, and the form of partial fractions used is summarized in the table below. Here we have linear factors. We have x plus a, x minus b, x plus c. That is the linear factors. How we can form its partial fraction? For linear factors, it becomes a over x plus a plus b over x minus b, then plus c over x plus c. That is for linear factors, where f x assumed to be of less degree than the relevant denominator and a, b, and c are constants to be determined. For the second factor, which is a repeated linear factor, in the denominator we have x plus a power 3. Why we call this factor repeated linear factor? Because x plus a to power 3 equal to x plus a times x plus a times x plus a. And so its partial fraction be a over x plus a plus b over x plus a squared plus c over x plus a cubed. We have another factor, which is quadratic factor. How we can form partial fraction for quadratic factor? You see here we have quadratic factor, but this factor is linear. We can treat as linear factor. So for quadratic factor, we have to form ax plus b over ax squared plus bx plus c. That's for quadratic factor. Plus c over x plus d. We treat the linear factor as the first condition. Okay, let's solve one example. Resolve 11 minus 3x over x squared plus 2x minus 3 into partial fractions. The denominator factorizes as x minus 1 times x plus 3, and the numerator is of less degree than the denominator. All the two condition is gained in this example. Then 11 minus 3x over x squared plus 2x minus 3, it equal 11 minus 3x over x minus 1 times x plus 3. It is a linear factor now. You see, linear factor. How we can form its partial fraction? Easily we can form it. It becomes a over x minus 1 plus b over x plus 3, where a and b are constants to be determined. Then if we find common denominator for this, for the a and b, it becomes a times x plus 3, a times x plus 3 plus b times x minus 1, and the denominators must be multiplied by each other. So it becomes x minus 1 times x plus 3. 11 minus 3x over x minus 1 times x plus 3 equal a times x plus 3 plus b times x minus 1. And we have the same denominator, so the numerator equal to each other. Then 11 minus 3x is equal to a times x plus 3 plus b times x minus 1 because the denominator cancel each other. To determine constants a and b, values of x are chosen to make the term in a or b equal to 0. Which value give us this condition? If we assume x equal to 1, then 11 minus 3 times 1 equal to a 1 plus 3 plus b, instead of x we put 1 minus 1. Then this term becomes 0. So 11 minus 3 become 8 equal to 4a. Then a equal to 2. To find b, you have to assume x equal to minus 3. Then 11 minus 3 times minus 3 equal to a times minus 3 plus 3 plus b minus 3 minus 1. This term equal to 0. So 20 equal to minus 4b. Then b equal to minus 5. Now 11 minus 3x over x squared plus 2x minus 3 equal to 2 over x minus 1 plus minus 5 over x plus 3. Also it equal 11 minus 3x over x squared plus 2x minus 3 equal to 2 over x minus 1 minus 5 over x plus 3. That is the answer. Let's give you some example. You can practice and find the solution and compare the solution with mine. We have this example. We have linear factors. It is partial fraction become a over x plus 1 plus b over x minus 2 plus c over x plus 3. And the solution is 4 over x plus 1 minus 3 over x minus 2 plus 1 over x plus 3. That is the solution. You have to practice by yourself. We have another example. For example, 2x plus 3 over x minus 2 squared. What is this factor? This factor is a repeated factor, so it becomes a over x minus 2 plus b over x minus 2 squared. You can find the solution. The solution is this. You solve it by yourself, then compare the solution with this one. For example, we have this example. We have linear factor and quadratic factor. Its partial fraction become, for the quadratic factor, it become ax plus b over x squared plus 2 plus c over x plus 1. The solution become 2x plus 3 over x squared plus 2 plus 5 over x plus 1. I hope this tutorial helps you to understand partial fraction. Don't forget to like the video and subscribe our channel. Have a nice time.